Hello everyone, we are back with the another training session, that is ANPR in high speed and varying topics. Okay, so when it is like in the traffic regions, we have one sort of thing that is the CCTV footages, okay, or the speedometers where we have the speeds located. Okay, so I'll be talking about the idea what you can try to make your solution, what you can just fit it in your solutions for the number plate recognitions of the vehicles. That can be a motorbike, that can be a truck, a car, anything, running on the roads. Okay, so we'll be dealing with some major terms, that is OpenCV, we'll be dealing with FCDs. Okay, a lot of terms are there. So we'll be going it one by one. All right. So I'll be talking about what is OpenCV, how it works. Hmm? Now you can see on this picture, we are having what we are having the images, images of what, or you can say like boxes, boxes of what the people walking, okay, or like moving over there. You can just say this is basically locating all the people, person, height, weight, the area they are occupying, and all that. Simple. Even the objects are being, detected there. So we will be focusing, or we will be, trying to know that what it is actually. Okay. So first we'll understand that what is OpenCV, or if we are doing this OpenCV with help of what or what technique we say as to be. This is computer vision. To simplify this answer, let us just consider a scenario like we all use Facebook, correct? Instagram, Facebook. So in Facebook, let's say that you and your friends went on some vacations and you collect a lot of pictures and you are trying to get it uploaded on Facebook and you did it. Hmm? Now, when you upload it, you are also trying to locate everyone's. Basically, that is called a tagging. Okay. So you want to tag your friends. So what you'll do is you go to a tag option, search by name, and then tag it there as well. Okay. So what we can do is here. Hmm? We can manually bring the names of the friends, like your friends, okay, and then you can tag it one by one. But that will take the time, right? It will take much time. So we know like already that Facebook is intelligent enough to automatically tag these people for you, whatever the faces their matches. So all these matches are done through a technique that is called as computer vision. So this feature, auto tagging feature, works on the uh, principle of computer vision. So you can say computer vision as an interdisciplinary field that deals with how computers can be made to gain a high level understanding, like for digital images or the videos. Okay. So whatever the idea here would be, will be to automate tasks that the human visual systems can do. Okay. So as a computer, should be very much able to recognize objects such as that of the face of a human being, or a lamppost, or an people walking over there, okay, or any object, bottle, anything, okay. So how it reads the images? It reads in the form of numpy arrays, a range of values which are there in between to 0 and 255. Okay, so for any color image, there are three primary channels like red, blue, and green. Okay, it's very pretty simple, like PGR, we say RGB, anything. So a matrix is formed for every primary color, and later these matrices combine to provide a pixel value for the individual R, G, and B colors. That's how it goes. Hmm? We'll talk about all these features one by one. Now, as the problem statement is INTL-IVA-01, which is the automatic number plate recognition. Now you can see I have put the images of some vehicles over there. Okay, and in the right hand side there is a running traffic vehicle. Sorry, photograph. Okay, of traffic ongoing. Okay, not very high, but moderate. You can see on here it is. Hmm? So what is our main goal here? One second. Hmm. So main goal is just to identify this. I should take another color once. This is to be identified. Hmm? These things are to be identified. on an ongoing traffic. Okay. So like you can see there are 1, 2, 3, 4, 4 plus 2, 8, 8 over there and 9. So you need to locate these things. So it depends on various terms again. The resolution of the image you are taking, the resolution of the device from which you are taking the images, then the quality of the image you located. Resolution is important. At what kind of resolution? At most, like what extent you can take the images after taking it, that what area you have selected, right? What area we have selected, what area we have detected of the number plate, how much clear it is. So there are some terms what will be important, what we would be discussing forward. Okay. Okay. Next. Coming. Yeah. So there are some process for NPR. That is the LPD, license plate detection, character segmentation, and character recognition. Meanwhile, I'll walk you through this all terms. What is this LPD detection? How you can detect it? Okay, all these procedures. Also, we'll be understanding that how these how this clarification of these images are done. Okay. All right. So very first thing, the very first thing is license plate detection. Okay. So here the first step is to detect the license plate from the car. Okay, whatever the car you are having, whatever the image it is having, the first step is to detect the license plate from the car. So we can use the contour option in OpenCV, which we are having it for detecting the rectangular bars there in the front of the vehicle's number plate. Okay. Then you can take the accuracy, which can be improved if you know that normally what car it is. Okay. What is the exact size, the color, and approximate location of the number plate if you're having. The accuracy can be increased up there. So normally, as I said, the detection algorithm will be trained based on the position of camera and the type of number plate in a particular country. Okay. Now, there are some Har cascades. Okay. I guess you know about the Har cascades if you're working in. So Har cascades will be able to detect the features. No, it will be important to detect the features, to locate the features. Yeah, if it is a face recognition site, so there will be a face recognition Har cascade, face locators. If it is a number plate recognition, it would be number plate recognition Har cascade. If it is animal recognition, there would be animal features. So our cascades are there for different terms, different recognitions. Okay, so we can use that also to make a good solution there. Okay, all right. So normally this detection is going to be worked on this Har cascade working also. Huh. Then an additional step we would be going next is that is character segmentation. So in character segmentation, once we have detected the license plate, we'll have to crop it out, the image what you have located. Okay. And then you have to save it as an image, right? That particular number plate what you have extracted. Once you have located, you can extract it there. So in this segmentation process, we'll be extracting that thing. Okay. And again, it will be done very easily through the OpenCV. Now, what we can do is now in the next step, that is character recognition. You need to recognize the number plate what have been given. It's a very simple step. Okay. Now, the image what we have located, that could be numbers, that could be alphabets, right? So that is actually in what? Character, right? It is a character. So we require a OCR there, optical character recognition, to direct all these as a number. So we'll be requiring this OCR. Okay. So we'll be using Pi Tesseract there. I'll be talking about that later, what exactly it is. Okay. So we'll be using on the OCR terms. Okay. So I'll be presenting my screen to you for the collab where, the Jupyter where I'll be using all these codes. Okay. First, we'll be looking on that how we can load images in colors, in black and white, and then we'll move forward for locating the R cascades, uploading the R cascades and locating it for different images. Okay. You can do these things, like there are several smoothing options like bilateral filter, Gaussian filtering, median blur filtering. Why these blurs are very important, I'll talk about it in further time. Okay, let me share my screen of codes. Okay, and we'll move forward with this. So we'll talk about this LPD and all the things very briefly about the character recognitions and the character segmentations and the license plate detection. Okay, also I'll be talking about the tesseract. Well, I'll show you here. If we go with the tesseract, this is the number plate detection, what I've said. Okay, here we have the cars, right? We're just locating it. Then we have the detection. We are using some different methods like edge detections, the blurriness, median blurs, Gaussian blurs, and finally we are taking a mask image there, as you can see, CZ20FSE over there. Okay. Next, we are just cropping it out, which is coming inside the character segmentation. After segmentation is done, you will be basically recognizing it, and that would be like whatever the vehicle number it is, you would be just recognizing that vehicle number there. Okay, so you can see it's 9-6, you are getting 3-6 there. So this is like depends on what, on the configurations you are taking. Sometimes characters are misreaded, so recognitions are important. So we'll use loops also to see the values of a particular car through multiple configurations of OCR. Okay, so we'll move forward. All right. This is Spy Tesseract I'm talking about, which is an optical character recognition tool for Python. Okay, it can read and the text or the characters, you can say, on embedded in the images. Okay, so it is what? It is a wrapper. It is a wrapper of Google Tesseract OCR engine. Okay, and you can see it has an ability to recognize more than 100 languages. Okay, now Har Cascade, what I'm talking about, is actually an ML based approach, machine learning, which is having what? Many positive and negative images. Actually, the features I'm talking about, what all it have is the features, what are important. Okay, so let's move forward. Let's start the coding now. Okay. Let me share the screen here. Okay. So firstly, like I'll show you some of the images. Okay. And we'll be moving forward. Like I have taken some of the images uh, on in ongoing traffics. Okay. On ongoing roads, I have tried to take some of the images. I can show you here, like, no, not this. Okay. So yeah, 1 second, and let's. Yeah. So you can see this image ongoing. Like I have just taken it randomly while driving. So these are the images I'll be using to locate these things. Okay. And okay, let's move forward. Let's create a notebook and understand how we can load images, how we can extract the number plates. Okay. So I'll be doing coding right now here in this area so that you can understand that how exactly the things are going to work. Okay. And you can use these methods actually to go in the to take the values in ongoing videos also, because from videos are actually what frames combined in one particular time to make it as a video. That's it. Okay. So what you are doing in a video, what we are doing is actually it is in the format of FPS, right? We take cameras, we take DSLRs, and we take it through various FPS. FPS is what? Frames per second. That is, in 1 second, how many frames it is capturing. Hmm? Okay. So that's the thing. If you can locate images in frames, you can locate it even in the multiple frames. Hmm? Okay. So we require OpenCV, we require OCR. Okay, all these things would have to be imported. I have written it here. I'll be going through it. So if you have PyTestAttack, it's fine. You can just get it here. If you don't have it, you just write it, pip install PyTestAttack. It will be imported. Once it is imported, you need to download it also. You can just go and download it. Okay. Also, OpenCV Python will be required here to go through it. Okay. So yeah, let's see, move forward. So I'm taking this OpenCV directly and will be showing images and all. Okay, let's start this. So this is CV2 and Matplotlib I'm using just for the plotting and the computer vision purpose. Okay, let's see it. Okay, so let's say we are loading a color image and a black and white image in two different formats. I'll be using it. Okay, let's see. Let's say that if it is a color image, I'm taking as like say IMG and this is cv2.imread. Okay, and we take an image name now. Let's say that image to be card image. We take a Skoda car or any cropped Activa, Swift, any image we can take it. Okay, and then we'll move forward with this. So I take this image, and as it is a color image, I need to write one over there. Simply, I'll be printing it. Okay. Meanwhile, I'll show you the shape as well. Okay, let me show it now. The shape is 1232 cross 1600, and that's of a color image. So 3 means three-dimensional image, that is BGR, which you can just go through why it is and such. Like you can see it from NumPy if you are working this. If you know like how NumPys are operated, obviously, well, because on the CVs you need to understand NumPys also. Okay. Fine. So you can see this is image, right, which is having a resolution over there and that's such things. Okay, now I can just display the image and that's simple PLT dot. I'll be using IMShow and that's the thing. We can use it, the X, CMap. So I'll be just plotting the image IMG. That's the image, right? So the image is there. You need to locate what? You need to locate the number plate. Hmm? So based on various images, I'll show you that where you can just locate. Now it is a colored image, right? The same thing if you want to take in black and white format, we would be just coming it here and taking it in black format. Black image, and let's say this is IMGB and IMGP. And this says 0 because it's not a color image. So I say it as 0 and that's it. So you can see no 3 is there because it's a 0 image, no RGB colors, completely black, white and black image. Okay, so let's plot this. And as you can see, like black and white images are probably going to be getting like this. Okay, and like if it is not defined and colored image, or if 1 second, let me see, CV2 dot I am show. We can get this IMGP. File is running outside, but not showing it here. This can well work in PyCharm. We just take and one second, let me see if I can go walk it through. But you can see, like, if I'm just using plt.arm show, it is giving what? It is giving you actually black and white image. Let's close the program, cancel it. One second, let me see if I can show you there in the PyCharm. I can show you this once again. Kernel is stopped to rerun things. Uh, one second. This has to be eliminated. Cut it down. Rerun the things. Rerun start ourselves. So it will print the things. Meanwhile, I'm going back to the PyCharm and just looking there and come up with terms. So the okay. So yeah. Oh, you have a car image over there. So if I can just copy it, like copy this. New non things the space that it's car one JPG. Thanks. Okay, meanwhile, when the PyCharm is executing, we'll move forward with the rest of the terms. Okay. So as you can see, like we can load images in these particular terms. Okay. You can resize it with different parameters. You can, find out the values. If it is a face, you can just go for the detect multi-scale function where you can just have the Har cascades for, like, if it is a face, you can just have frontal faces. If it is a location, you can have the particular Har cascade for that. I guess my PyCharm is working now and I can just show you about CV2. I need to import it once again. Compare, modify. Okay. File, project settings. Interpreter is having not MPy is there, OpenCV is there. Yep, it's okay. It should work. CV2 is not defined. Import CV2. You're gonna look in this, run it. Yeah. So once again, let me share my PyCharm screen to you. So this is my PyCharm screen. Let me just share my complete screen once again. So yeah, I'm like this. So yeah, I guess like in this, I can make you see this particular thing, this pie chart. Okay, if not, 1 second, it's still not visible. I can see screen one. Share this. And now it's okay. So simple, like what we are doing is we are just loading images now. Instead of printing the shape, what I can do is I can print the img p dot, or you can just show the particular image, right? So we can just write even that what image it is by using cv2 dot im show. Okay. You can write a black image of imgp. Let me just execute this and see what we get. Okay, so we need to write a wait key also, because here the image is just showing and it's not waiting. So I'll write the wait key. This will help you to, like make your image wait for some seconds if you want. Okay, if you want it for you know, some milliseconds, it can wait over there. What's it? Yeah, let's execute this. Once it is executed, you can destroy window once you execute. CV2 has no attribute of wait key. And what's it going there? Okay, let's come back, guys, to our this area, because loading images is not a basic goal. Okay, I think you are clear with this. You can just see that if you want these to be executed, this is a black and white image. That's all. You just understand with this, and will not waste time on this particular thing. And this is the output. So this is a black and white image. Just go with this. Okay, fine. Now, when we come up to the filtration parts, because filtration parts are important for any number plate detections. Okay, like 2D convolutionals. Okay, or like OpenCV's original and averaging values, or the blurred values, or median blurred values, Gaussian blurred values. So we're talking about this here in the filtering images area. Okay, or else like I can just show you the area where we have this filtering images we are loading, right? Basic operations. I don't know why it's loading very slow. Yeah. So you can see, like I have imported all this NumPy CV2 and Matplotlib. Just simply loading an image is Skoda car. Okay, we are setting a kernel value. What is this kernel? What it is doing there is like once over there. What is the working of it? It is just an operation where it is working like this, that this kernel is to be kept above a pixel, and it will add, this is by 25, as you can see there, right? Okay, it will add all the 25 pixels below this kernel. Okay, and then we'll take the averaging value and replace the central pixel with any new average value with that. Okay, so this operation is continued for all the pixels in the images. Okay, so we'll just execute this and we'll move forward with the other images. So you can see like CZ0, CZ20 FSE, and here in the averaging it is coming originally something different. Execute this. This is the averaging image. Okay, now we take it a blur image, nothing but just using the blur option, blur function. And this is blur, averaging, original, changing the font size of the things. Next, the Gaussian blur, as you can see there, the blur and the Gaussian blur is actually a bit different. In the Gaussian blur, you can just blur the particular area without, affecting any of the OCR or the characters. So this is a Gaussian blur. Moving forward, we have this median blurred Okay, where you can see like it is very clearly mentioning or very clearly visible the particular area that is CZ20 FSC as compared. This is an original image, and you can see a blood image there in this area, right? A Gaussian blood image, basically not a a median blood, and you can see this area. When we go to the Gaussian blood, let me execute this. Yeah, and when we come to this bilateral, I guess this is Gaussian blood. Yeah. In the Gaussian blood, when you look at, just simply if I can just paste only the Gaussian one, that's 1, 2, 1. One, two, two. So we can see the Gaussian blood and then the median blood. Okay, so there are changes. You can just see how it is coming. Okay, and then we can have this particular way for bilateral filter. Okay, I'll take the same thing again. Skoda will be okay. So this is a bilateral filtering, okay, where we are basically targeting on the image we have recovered with. Okay, so this is how it works. That's all. Okay, moving forward to this area, we'll be talking about now how these things are working. Okay. So we are importing all the dependencies like NumPy, Matplotlib, CV2, PyTestRect, as I said, and then you need to give the CMD path or the exe file you have, load it. You need to give it there to take it. Okay. Basically, we'll be reading images. So firstly, what I'll do is I'll take a Skoda car, Skoda image. Okay. Coming. Yeah. So CV2 is not defined. Okay, into this. Execute this. Yeah, done. So I'll plot the car or plot the thing what we have read it. Okay. And now see, like the image what we have read it is being plotted here. Okay. Now we are building a function to enlarge the display for the user like you. Okay. To clear it more clearly, to see it more clearly. Okay. So this is a function basically the image is taking and the scale factor is being given. By what scale factor you need to enlarge your image. So this is the width. The width is being given shape of 1, like numpy array if it is, and the shape as we discussed, like here also in the Python pie chart was not having any weight key, so let it remove. The showing option was there. I think that this is due to the update. Some security patches and things have to be updated. So I'm not updated in thing. I think that's why it's not working. But yeah, like if I can show you there in my another PC, I'll show it once again, like by running whether it is working or not. Okay, fine. All right, let's come here. So you can see like scale factor is being given, width and height is being given, the dimensions like width and height accordingly, plotting the figure, plot like axis is off and image. So enlarging, put up the image name, the scale factor, and this is the image as you can see. Okay. Now, moving next is importing the R cascade. So once you have imported it, you just write it there. So I'm having it in my particular directory. This is R cascade. So I'm just uploading it here. Okay, just loading it. And then we have setting a function to detect the card plates. That's a very simple thing. You are just putting in the multi-scale detections and all, like simple, like how you locate the faces, nothing else. Okay. And that also, yeah, running it again. So let me run this, then this one also. So now car speed thing is not defined. I guess this is not defined. Execute this. This problem. I think I have not executed them. Yeah. So enlarge image, as you can see now. Execute this. Enlarge image now. As you can see, like here, we are locating this particular location, like CZ2EFFE. The number plate has been located. Okay. Resolution should be good. That is important. Next. Now you are now locating the image or you are basically extracting it with the tesseract OCR, the optical recognition. Okay, so let's run this. Nothing much you are doing here is just you're taking the carbonate cascades, detecting the multi-scale with some scale factors, minimum number of neighbors, and you are putting a box over there. That's it. Enlarging the image. So now when we run this, this would be the character segmentation process. Okay. So this is character segmentation where you are taking the image only of the detected number plate. So now let's just make it to the grayscale. Why we are grayscale? Taking it by grayscale, right? You can see like how it is converting it to a grayscale. Okay. If you want to convert it, if you want to load anything, you can just make it that. Otherwise, you can just plot. And I guess like if you just go in this C map equals here, you can work in this because I guess C map goes there and you can make it to a gray if it goes here. Well, yeah, that's it. Okay. So you can paste it, sorry, you can run this like by giving a color map value. If you want some color bars accordingly of how this particular value is generated. So you can give a C bar value to, okay, in the heat maps or the plottings accordingly, you can just give a C bar value and that could be anything like if you just say C bar you want, I guess like here if you just run it, you will not be getting because it's not a very heat map plot or any kind of visualization. It is just an image you are executing and that simple thing. Okay. Coming back here. Okay, so we are now, which line it is? Okay, we are now converting it to grayscale, and as you can see, like it's converted in the grayscale. If you don't want to plot the axis, like as you can see, we are writing every time the axis equals to off, and we see here in this particular thing, we are getting this, right? So if we write PLT dot the axis, and here if we just write this as OFF, we are not going to get any axis there. Okay, and you're getting a couple of values for what you can also write PLT dot show to remove these things. Okay, that tuple will also will not show to you. Okay, now main thing, come here. Detection, sorry, grayscale has been done. Make it median blur. Only to get, like if you just make it median blur, what will happen? All these particular things like the other objects of the vehicle will be, like made blur. Okay, and only the like characters what are there would be highlighted, and that would we want. Execute this. Done. Now it is the character recognition part. So basically what you are going to do is now you are going to find it out. What you are now going to find out the characters or the numbers in the number plate or the characters in the number plate to a string value. You are going to extract it from the card plate now using the configurations, the different configurations we can use. Okay. So if we execute this, we get a number that is CZ20FSE accordingly. So we can test it in all the PSM values, all the configuration methods, and you can just see like how the number comes. Okay. With every PSM values, every configuration values, we are getting this particular number. Okay. So like you can have any sort of images. Okay. What I said, this is the most important thing. If you can locate this, you can read them by using the filtrations, by using the filtering methods, by filtering the images, or by going through some detection scales, you can improve its particular accuracy. So a model you can just create which can go through all of these things and just simply, whatever the image you give, it can just go and detect and just simply will give you an output that this particular string is this, or this particular number is this. I'll show you some of the things using the Indian cars. Like let's take, I'll show you that live car detection also. What I just clicked randomly in a moving vehicle. So you can see the enlarged image, guys. Okay, and this is the area what we need to locate. As you can see, the number over there, we need to locate this particular thing. So we'll be again, coming directly to this car plate image detection. Okay. Our cascades are fine. We don't do much over there. Just simply go and detect this. So as you can see, we are successfully locating the particular car number. Okay, and that's why it's simple. You know, now you can, like fetch the value from there. Okay, the resolutions should be better while taking images. You know, so whatever the CCTV footage is or any related things are there, that should be very high to have it good sort of things. Okay, so that is what this particular ANPR says. We can have any number of images. Not only this, I can show you some more images with relatively have Swift JPG. This is also randomly clicked by me there. Okay, so this is also the same area what I have used. So you can see this is an area. Sorry, this is the car. Now our work is to locate this particular number plate, right? So what we'll do is again, let's come in the car plate location and just go with this enlarged image and detect it first of all. So you can see this particular car, the number plate is being located. Okay, fine. So you need what you need to extract it now. You need to find at what particular scale. Okay. If you're not getting the complete, value, you can increase your scale factors. You can make it much more clearer. Okay. And you might get the value if it is not coming. What's the local variable before assignment? Can increase this, increase this, increase this. Okay. All right. Like you can just run all the things again if it is not giving any errors. Let's see what we get. Come quickly. In case like if you are not getting any correct loadations, correct load of the images, you can change the scale factor. So it depends on you what scale factor you want to put, right? That you can just detect. So again, that's what referenced before values. Function to retrieve the car number of functions. Okay. All right. Just where we was changing the things. 1.4 was scale factor. Okay, fine. No problem. You can just get at the back things what it was and execute the spread pointer. Okay, well, let's not change now. In the previous recognition only, we can just change it here, scale factor to 5. I'm getting any problems there. Some bit more changes is required there. Okay, so you can get these particular thing actually by changing the scale factors. Okay, the scale factor if you change, you will get the particular area. However, you are locating it. It's not like you are not locating the particular image. The image, if you see, will be located. Okay, fine. All right. Let's escape. Get back to 1.1. Because this scale factor also matters by what scale factor you are just changing the images. Okay, fine. All right, so this particular block of code is also fine. Let me come here back to my PC. Okay, so that particular block of code was also okay. All right, so these are the things like what we can focus on the particular areas for the number plate detections. Okay. So I guess you might have understand how things are gonna work. Okay. And I guess you will be coming with a good solution there for this particular problem statements. Okay. So if you have any kind of doubts, if you have any like queries related to any of the particular topics related to whatever the sessions I have taken, right, you can just have the mails to the authorities there. I'll be glad to give you the solutions based on that. Okay. So yes, I guess your solutions, whatever you have made, would be very highly appreciated because everyone is contributing in particular things. So make good ideas. Okay. All right. Jai Hind.